Great. So we all know how important it is to be able to ensure the quality of your data, and so that you can feel confident that there are as few bugs as possible. So we've been improving how Cypher interacts with its types, and that's what we're presenting here today. Now, at a storage level, we've always had types. I mean, it's an imperative part of a database to be able to store strings, integers, dates, and so on. However, up until recently, it has not been possible to use pure Cypher to interact with those types. So you haven't been able to query if a data value is of a certain type or enforce those types using constraints. Now, in Cypher, we have around 16 different types. As you can see here on this slide, there's quite a few, but there's also the supertype of any, the subtype of nothing, as well as dynamic union types. We've also added a whole range of different synonyms to make it easier when you're writing your Cypher queries. So I'm going to go through a couple of our more special types. So firstly, we have empty lists. An empty list can be defined as a list of nothing. And this will remain so until you add at least one item to the list. So if I were to add like the value Boolean, for instance, we'd now have a list of Boolean not null. Another special type to note would be the property value type. So a property value type includes all of those types that are storable in the database. So that includes strings, integers, floats, etc. What this doesn't include is values like maps, nodes, relationships, because you can't actually store those as a node or relationship property. So this one's actually quite useful if you want to check whether or not the value you have in your query is going to be then storable later on. And one final note of a special type is a closed dynamic union type. So this is more a combination of types. So if you don't care whether or not your number is an integer or a float, or perhaps if it's a list of integer and floats, then you combine all these together. And what use would all of these new types be without being able to use them? So in 5.9 earlier in the year, we added some new constraints. So we now have node property type constraints and relationship property type constraints. So for example, this allows me to now enforce that my movie title is of type string. So that means I won't have any bad data where my movie title is perhaps an integer. And then these are part of Enterprise Edition only. And alongside these, we've also introduced type predicate expressions. So these are a handy way of testing whether or not your expression is of a certain type. Now, an important thing to note here is that all Cypher types actually include the null value. So this can be a little confusing, but if I were to say, is null of type Boolean, I would actually receive true. This might not be wanted actually, so you can say null is of type Boolean not null, and then you'll actually get false back. We've finally added, very recently, as of the 5.13 release earlier this week, the value type function. So this is a neat little function which will return a string representation of the most precise value type that the given expression evaluates to. So in this example, I want to know what the value type of the number 1 is, and you'll get the string back integer not null. This works similar to how in other programming languages have a type of maybe keyword or function, but in Neo4j and Cypher, it's called value type. And finally, we've also been working hard on unifying our documentation and changing how the signatures in our show functions and show procedures commands work. So as you can see here, we now have the new types shown in the signatures and even closed dynamic union types. As you can see, node or relationship or map for the properties function. And we believe this makes it more usable and easier to read. Now, to shine some light on how we use these new features, I'll now pass you over to Louise.
So first, we will look at our data set for the example. So we have created a small toy data set. which consists of our Cypher surface team at Neo3j, where me and Gemma are working. So this data set contains nodes for each person, me, Gemma, and our colleagues, as well as nodes for our 2 team dogs. Each person has 2 properties, a name and is node presenter, while the dogs only have the name property. And as you might can see, even if it's a bit small here, the is node presenter data is a bit of a mess. Some of it is strings, and some of it is Boolean, and some of it is integer, and sometimes it doesn't exist. So you can see, for example, that Gem has is node presenter with the Boolean true, while I have it with the string true in this data set. So we would like to clean this data up, and we think it's reasonable that you either is a node presenter or you're not a node presenter. So it would be reasonable to use a Boolean. So then we can use our new property type constraints. So let's try to create a constraint. This is the syntax, similar to other constraints. You will call it a name. In this case, is node presenter. You do it for a specific label and a specific property, and we use this : notation, like that it should be typed Boolean. So let's try this, and it didn't work. And the reason is that we already had conflicting data. You can see that the error message says it's unable to create a constraint because we already have a node where the property is nodes presenter is of the type integer. And this is similar to how it would fail if you have, for example, a uniqueness constraint where you have duplicate data, or existence constraint where the property doesn't exist for all nodes. So let's inspect our data a bit closer to see what we can do about this. So first, we will just match all the nodes. In this toy example, we only had 7 nodes, so we can just do all node scan. If you do this at the real world example, you would of course use any labels and indexes as usual to make it faster. We then return the name, the node presenter, and use the new value type function to check the type of the isNodes presenter property. We can see here that for Nadia and Gem, the value type is Boolean, not null. So it's either true or false. For Natra and Love, it's an integer. For me, it's a string, and the dogs doesn't have this property. So then it will come out as the value type null. So let's then clean up our data. And this we will do with the following query. So again, we match all nodes. We use a set clause with a case expression with 1 branch for each different case. So first, if the isNode presenter is null, like for the dogs, we assume they are not nodes presenter and will assign false. If the isNodes presenter is of integer or string type, which we change with this, we check with the new type predicate expression. And in this case, we use the built-in conversion function to Boolean to change it to a Boolean. If it already is a Boolean, we'll keep it as is. And then we have else branch, which will not happen in our case, but just to be sure, we will set it to false in case it would be something else. And after we have done this query, our dataset will now look like this. So all the nodes have both properties, and the isNodes presenter is either true or false for all of them. Now we can try to apply our constraint again. So same as before. And what will happen now is it worked, because we no longer have any conflicting data. So now I've showed you how you can kind of investigate your data and how you can clean it up. But of course, while you have cleaned it up, you want to keep it clean. And this is where the constraint come in. So if we now, after adding the constraint, try to add a new team member in our team called Alice with isNodePresenter false as a string, it will not work anymore because of the constraint, and you will get a good error message telling you that the node with the label person required the property isNodePresenter to be of type Boolean, but it was a string. So now when you have seen how you can use this new functionality to inspect data, clean up data, and keep it clean, you might want to try it out yourself. We have a lot of new docs resources for this. Most of these are in the Cypher manual around both the new constraints, the type predicate expression and value type function, and also for all these types and synonyms that Gemma showed in the beginning. To access all of these features, you need to use the Neo3j 5.13 release that was released just a few days ago, or you have to be on Neo3j 5 on Aura. And last, I just want to say that we would love to hear any questions and feedback that you might have. Thank you.